In this video, I'm going to restore and then test this Heathkit A-8A amplifier. This is a little integrated amplifier. As you can see here, it has a number of different inputs and it also has tone controls and volume control. I picked this amplifier up on Craigslist, and it's a pretty rare amplifier, the A8A specifically. Heathkit made a bunch of little integrated amplifiers like this, and some of them are more common than others. For whatever reason, this is one of the less common ones, so you don't see these very often. So hopefully this should be an interesting video. Yeah. And so I got it with tubes. Tubes came with it, thankfully. However, they're not matched or new. So when I do the test, I'm going to swap them out. But anyways, the tubes that this uses is a 6SJ7 in the first position, another 6SJ7 in the second position, and then this is a 6SN7, and then these are both 6L6s. The person who sold me this amplifier gave me two random 6L6s from their parts bin. As you can see, they're not matched in terms of their manufacturer, so I put them on here just to show how I got this amplifier, but I will be swapping these out for a proper matched pair of tubes when I do the testing. And then this back here is a 5U4G rectifier in one of the big ST type bottles. Yeah, so these are all old tubes. None of these are new manufacture. And yeah, so on the front we just have our inputs, one for mag phono, one for the mic, and then one for the crystal phono. The crystal phono is going to be the best one to use as an auxiliary input, to just use this as an amplifier. The first two settings have more gain, as we'll see when we go over the schematic. Then there's a volume control, pretty straightforward, and there's also tone controls for bass and treble over here. And yeah, not too much to say about this amplifier. It doesn't have a power switch, pretty basic. And yeah, for our transformers here, this is this power transformer. I'll see if I can remove this from the mount and show you. This power transformer is a Chicago transformer, and the output transformer over here is a Peerless transformer, a Peerless S516A. So pretty nice iron on this thing, and I'm really excited to see how it performs once it's all restored. So without further ado, let's get into the circuit and take a look at what we're dealing with here. Alright, so this is the schematic for the Heathkit A-8A. It's the best one I could find on the internet. It's from Audio Karma, but it is not phenomenal. The resolution is very low. It's about 50K. I'll put the poster of the schematic in the description just to credit them. I'm forgetting the name right now. But anyways, it's from Audio Karma, and I'm very grateful for it, but the resolution is low, which is why I have it kind of zoomed out because it looks better that way. Anyways, let's get straight into it. So this is the first 6SJ7, the one that the brochure refers to as the preamp. So this is a preamplification section, and you can see here we actually have two different RCA inputs. One goes into the first preamp 6SJ7 and the other one doesn't. This input is for the magnetic phono and the crystal phono, which both require more gain to reach a usable output level because they're lower level sources. So those low level sources go into this, which is just a common cathode pentode amplification stage. Of course, you can see we have 5 electrodes, so it's a pentode, and it's a simple common cathode setup with a cathode bias resistor here, bypassed by a 10 microfarad capacitor. And then we have our grid leak resistor, our plate load resistor, and our screen dropping resistor and capacitor for some decoupling right here. So yeah, that's our first stage, and the plate goes over into this through a coupling cap, and this is our input selection switch. So you can see that this is the conductive portion of the input selection switch, and so in this position, it is connecting these 3 pins right here. So one of those pins, of course, is the input from our plate of the first 6SJ7. That's the middle pin here. And then the other pin right here on the left-hand side, I'll start with this one, goes into the tone control circuitry, and then that goes into the grid and to the rest of the amplifier. So that's what this pin connects to. This pin on the far right here actually connects to a 15K resistor in series with a 0.01 or 2, I can't even read that lettering, microfarad capacitor, and that capacitor goes to ground. So these are basically in series shunting the signal.
And I'm guessing this is for some sort of tone control, not tone control, frequency compensation for the magnetic phono input. I'm not a big phono person. I'd never use phono stuff, so I don't know a ton about that, but I'm guessing that's what the purpose of this is, because when you move the switch one position to the left to the mic input, you can see that the conductive portion will move one to the left, and this resistor and capacitor will no longer be in circuit when you have a microphone connected. So those are specific to the magnetic phono. So yeah, when you have this input switch set to mic, you will just be getting these two pins right here. So you'll just be getting the first 6 SJ7 straight to the tone controls and the rest of the amp. When you move the switch all the way to the right to the crystal phono setting, you'll be connecting this pin right here and this pin right here. And of course, that's just our second crystal RCA input right to the tone controls and the rest of the amplifier. So that completely bypasses this first amplification stage altogether. Here we have our tone controls. They are actually mislabeled. I'm sure of that because I checked the wiring diagram, which also there's a picture of online, and these are definitely reversed. So this should be bass right here, this potentiometer, and this one should be treble. Anyways, you can see this is just a RC filter. Here's the resistor, here's the capacitor, and then you've got another resistor in series here. This is a kind of a interesting tone control circuit. I'm not 100% certain I understand how it works, but it kind of makes sense when you think of it as basically if this resistor is set to the maximum setting, 300 or 500K or whatever that says, I think it's 300K, then you basically have a voltage divider and a capacitor in kind of in series here, and at very high frequencies you will be shunting to ground, so you will have this resistor kind of in circuit, and at lower frequencies, well, this capacitor will block the current from flowing at all, so this won't even, the voltage divider won't really be in circuit at all, and you'll be getting the full gain. That's my understanding of how this works. So you actually, I think the way this is implemented, it kind of gives the amplifier a gain penalty to implement this tone control. But I could be wrong on that. If anyone has a better explanation of how this tone control works, if I'm totally off base, please let me know. I also don't deal with tone controls that much, although it's probably something I should get better with, kind of RC and CR networks and stuff, but I think that's how that works on a basic conceptual level. So anyways, those are our tone controls right here. And then you go into our volume control, of course, just a simple potentiometer, voltage divider right here. That takes you into the grid of our next 6 SJ7, which is pretty similar to the first one, just another common cathode pentode voltage amp stage, except here you have the feedback coming in. You can't really see that on the top of the schematic, but that is the feedback connection that goes through here and connects up here. So yeah, so that's the feedback connection, and you have a 10 microfarad capacitor bypassing this 1K, but you still have the 100 ohm in circuit there regardless. So this 100 ohm, I think, is purely there as a voltage divider for the feedback. That's why this is split into two sections. Of course, you can't have a capacitor bypassing the whole thing, but they wanted to keep some of the gain by having most of it be bypassed by a capacitor, so they just only bypass the 1K, and you have the 100 ohm on the bottom here. Anyways, that from that plate, you go over to here into the next stage, which is just another common cathode triode stage using half of our 6 SN7 right here. Interestingly, you can see this grid leak resistor right here is shunted by a 220, I think that's MMF, I think that's picofarad, I forget, that would make sense, 220 puff capacitor right here, which is just shunting the plate of this 6SJ7 in essence. I usually put these on the high voltage side of the coupling cap. Not sure what the logic is, but for putting it on the low voltage side of the coupling cap, whether it makes much of a difference, I don't know. But anyways, that's shunting the output of the 6SJ7. And then, yeah, so here we just have our normal common cathode triode voltage amp stage, super simple here. No cathode bypass cap right here, just a straight 2.2K resistor. And then our plate here is actually directly coupled, 100K plate load resistor on our 6SN7, and then our plate is directly coupled to the next half of the 6SN7, which is a simple concertina phase inverter. You can see 47K ohms on the plate, 47K ohms on the cathode, so the split load, and then you get simple cap coupled to the grids of each 6L6. So yep, very simple driver stage, just a straight up cathodine concertina, whatever you prefer to call it. And yep, normal cathode bias on the 6L6s, no bypassing there either. And yeah, so that's our pretty straight. Oh, actually no, that looks like it is bypassed. This 10 microfarad or 20 microfarad capacitor looks like it actually is bypassing that. Yep, I think so. So yeah, that's part of the CAN capacitor, which means that that probably is kind of a long lead. I haven't really looked in there, but anyways, that is being bypassed by part of the CAN capacitor, it looks like. So yep, our output transformer over here, obviously push-pull output transformer, a bunch of different taps for different voltages, selection, I mean not voltages, impedances for your speaker, so you can strap this for 4, 8, or 16 ohms. And then of course for our power supply, vacuum tube, full wave rectifier, pretty straightforward. Switch is on the back of the treble control. Earlier I said there's no switch, but I was wrong. There is a switch and it's on the back of the treble control, which is super annoying. That switch is probably shot. The treble control is really sticky, so we're going to have to reckon with that. I really wish this just had a normal switch, but I don't want to drill into this thing or mess it up in any way, so if I have to, I will retain the switch on the back of that treble control. I actually might just replace that entire potentiometer because it's so sticky and terrible. But anyways, yep, so that's about it for this schematic, and we will well, one, I guess I kind of forgot to mention that you do have over here a step network for our negative feedback. So there's a resistor and a capacitor here. It looks like 100 picofarads. Yep. So that's just another minor thing. But anyways, I think that's it for analysis of the schematic. That should give us a basic sense of what we're looking at, and we can get into restoring the actual amplifier.
Alright, so now that we've taken a look at the schematic, this is what the underside of the Heathkit A-8A looks like. You can see we have a bunch of our wax capacitors, which are going to be replaced, as these are the problematic capacitors. And we also have some old electrolytic caps right here. And then you can see here is our output transformer, the leads from our output transformer. Here are the leads from our power transformer. And then we also have our multi-section CAN capacitor in the middle right here. So without further ado, let's just get right into recapping. I'll do this as a time lapse, I think, and I'm going to start with the electrolytic caps, and then we'll move on to the wax capacitors. All right, so these are the capacitors I replaced in the first round of recapping. These are electrolytics on the left, and we have our wax capacitors on the right. And I did leave 2 wax capacitors inside of the amplifier. The reason I did that is because they are soldered to the tone control circuitry, the tone control potentiometers, and I haven't decided yet whether I want to replace those potentiometers. I'm going to see whether or not they have continuity issues, whether or not the resistances look right, and whether or not they will rotate smoothly. So what we're going to do next, before I make a decision on whether I want to replace those last capacitors now or wait until I get new potentiometers, is I'm going to put the amplifier back on the bench, and we're going to lube those up and maybe spray some contact cleaner into them, and then see how they perform. All right, so the first step now is going to be removing all of our chicken head knobs right here. So let's do that. All right, so next I'm going to give each of these a quick shot of WD-40 just to kind of release some of the seized up grease that's inside of these. All right, so I finished lubricating and cleaning the shafts of the potentiometers. What I do is basically spray a little WD-40 in there to loosen up kind of the grime and the dirt, rotate it around a few times, and then I apply a 3-in-1 multi-purpose oil, that's the brand, and I just move the potentiometers around. And the 3-in-1 oil mixes with the dirty oil that's already inside the potentiometer and kind of draws it out. And so by wicking away the dirty oil that's drawn out when it gets mixed with a 3-in-1 and just repeatedly applying more and more 3-in-1, you can gradually kind of dilute and wick out the dirty oil inside these potentiometers, and that leaves you with a much nicer action. So, you know, I'm sure many people have different ways of cleaning pots, but this is one that I've kind of arrived at through doing this a bunch of times, and this method seems to work pretty well for me. So anyways, so that's how I got these working again, and this one was like completely seized up when I started. This is the AC power, so the power switch and the treble, so it's very nice to have this one working properly again, and you can hear that click, and it rotates very nicely now. So I'm happy with how that turned out, and then the bass, of course, is nice as well, and the volume. One thing about the volume pot that's a little bit annoying is that the volume pot shaft has a kind of a cutout, a notch for the set screw, and so you can only really screw the set screw in one place. And of course that means that the knob can only be in one orientation. And I think whoever installed this pot wasn't really thinking about that because when the volume's all the way down, it's not pointing down as it should be. It's pointing up here to the side. And yeah, so that's a little bit annoying. And you'd think I might be able to loosen the nut and just rotate the whole potentiometer around so that it's pointing the right direction. But unfortunately, the leads have been soldered on the other side such that they're kind of short, and it wouldn't be possible to rotate the whole pot without the leads would prevent you from rotating it. So I'm not going to bother with that. It's just a little bit quirky, but it's fine. I'm not too concerned about it. And then of course our input selector over here works well as well now. So yeah, I'm happy with how these turned out. I was thinking I might have to replace them because they were so sticky, but usually these things clean out pretty well if you just stick at it and keep rotating them around and lubricating them and cleaning them. So that's nice. However, I still need to make sure that they're good electrically, of course, because if they're not good electrically, well, I'll still have to replace them in that case. For these three, they seem pretty well sealed, and my experience with these big old sealed potentiometers is that they typically don't really go bad electrically. They're usually fine, so I'm not too concerned about them. They also have quite a bit of corrosion on the back, and it could be cadmium, and I'd rather not disturb that and get powders everywhere. I'd rather leave these sealed and intact if possible, and not try to be getting in there to clean them or put contact cleaner on them. So I'm going to hope these are just fine as they are. This one I will clean the back with contact cleaner because this is an open rotary switch. It's not sealed or enclosed or anything. It is just open, so there's quite a bit of corrosion and black dirt on the contacts of this, as I'll show in a second. But that's going to be the next task, is going to be to clean this one out with contact cleaner and then test the other three. All right, so as you can see, done contact cleaning the rotary switch. It's looking much cleaner. It was almost jet black earlier, but now it's substantially improved and hopefully will perform quite well. So next, let's get on to the three tone control potentiometers and checking them out to make sure they all work. One thing I will note before I start is that look at this resistor right here. It is obviously non-original, as you can tell, because it has this white body, and the other resistors are all, our normal brown carbon composition resistors with the color bands on them. So this is a non-original resistor, and the schematic says this should be a 100K resistor, but this is a 1 meg resistor, and it's written on the body of the resistor in pencil, although you probably can't see it from this angle, but I verified that this is in fact a 1 meg resistor. So I don't know why that's been put there, but I am going to replace that with a 100K because that's what the schematic calls for, and I'm pretty sure this 1 meg seems too high for me based on what the circuitry is doing here. And also, I'm guessing someone just put this in there on accident, or maybe they were modding it or something. I don't know, but I'm going to remove that. And so another thing I did was I cut the leads on the tone control capacitors, as you can see. I just wanted to make sure when we did our measurements of the pots that DC leakage through those capacitors wasn't messing up the measurements, and they're getting replaced anyways, obviously, so it doesn't really matter. So yeah, let's start with the volume control first. And one thing I do want to note about this tone control circuitry before I start is that the bass control and the volume control, which are these two right here, are actually they both have a current path to ground. So when I measure the volume control, it is actually in parallel with the wiper and one of the other leads of this bass control potentiometer. So that's why we'll observe this weird behavior that I'm about to show you, but it doesn't mean the pot is broken. It just means that that's how this circuit is designed. So we start at 32 ohms, and this is at minimum volume, so that makes sense because I'm measuring from the wiper of this volume control pot to ground. So that's what this measurement is. And so you'll see it starts at 32 ohms when the volume is at the minimum. And when we increase the volume control here, we'll see the resistance goes up as you would expect. And it goes to, in the middle of the adjustment range, it's about 137, 138K. But when we start to go further, it actually decreases back to about 40K. And this might seem odd, or maybe defective, but in fact this is how the circuit is supposed to perform, because what's happening is when the wiper gets close to the non-ground side of the potentiometer, it's actually has a lower resistance path to ground through the base control. And so what you'll see when I turn up the base control is that the resistance between the volume control wiper and ground actually increases right here. So now once the full base control pot is in parallel with the wiper, you'll see we get the value you'd expect, which is 250K, because it's 500K and 500K in parallel. So anyways, this pot actually does work fine, the volume control pot. It just has that weird quirk that makes it a little weird to measure. But yeah, so that seems to be working fine. Now let's move on to the base control, which I think we just saw works fine, but I'll verify it. So it starts at the left at about 50 ohms, which is fine. Should be some low value, and then it does increase. It increases as we go, and the value of this one is not dependent on the volume control pot, because this one doesn't. The path to ground does not go through the wiper. It goes through the entire track of the volume control pot. So that's why we get 500K and 500K in parallel. It's about 250K. And so that works as well. And then lastly, let's try our treble control pot. And the treble control pot is not in parallel with either of these other two. So it should just give us the actual reading when we do this. So it starts at a weird value because this is when the switch is completely off, so the amplifier isn't even powered on, and it does weird stuff. But once we turn it on, you'll see we get what you'd expect, the low value, about 90 ohms in this case. And then as we turn it up, the value, of course, increases to about 470K. Now this is weird because this pot on the parts list is listed as a 1 meg pot. And there's nothing else in parallel with it. As you can see, this lead is not connected to anything at all. So there is no other explanation except for this pot actually does measure only 500K about. And so I'm not sure why this could be. One explanation, of course, would be the pot is defective, but this seems really unlikely to me because it works so well throughout the entire range. Usually when a pot is defective, you'd expect, it to have jumpy resistance and you wouldn't expect the whole entire track to be half of the correct value. That just wouldn't make any sense. So I don't think it's a defective type thing. I think this pot is actually just a 500K pot. And either the two explanations I can think of are either the person who built this amplifier purchased the wrong part and they got a 500K volume control and AC power pot rather than a 1 meg one, or the other explanation would be that there was an on-the-fly revision made to the design of this amplifier that changed this 1 meg pot to a 500K pot, and maybe that's just not reflected in the parts list that I have from the internet. Totally possible either way, but I'm of course going to just leave this 500K in here and see how well it works. If there's a problem, we could consider replacing it, but I don't want to replace it unless it's necessary, and since it seems to work, I'll just leave it for now. So anyways, that's all three of our pots. They seem to work perfectly well. I'm very happy with that. Happy I don't have to order new ones, at least not yet. We'll see how it actually sounds, of course, and whether there are issues that aren't apparent from this quick and dirty test. But, so far so good. So the next order of business is going to be replacing this 1 meg resistor with a proper 100K resistor and replacing these two wax capacitors. And once we're done with that, we should be ready to fire this thing up and see how it does. Oh, actually, I do need to solder in also all of the recaps I've done. I didn't solder any of them. I only kind of mechanically connected them. So once we do this and this, we will solder everything and then we'll be ready to go. All right, so at this point I've recapped everything except for the CAN capacitor, and I'm a little bit iffy on the CAN capacitor. So when we start this thing up, what I'm gonna do is, right now I have the 5U4 G rectifier in the rectifier slot, but I don't have any of the power tubes or any of the signal tubes in here. I only have the rectifier in here. And so what we're going to do is I'm going to power this up at very low voltage and leave it running at relatively low voltage for maybe an hour or two before I try putting in the audio tubes and giving it more voltage. So that's what I'm going to do now. And I do have this, I use this panel to control my variac and my dim bulb tester. The variac is off screen, but I have this hooked up to a variac, and I also have the dim bulb tester in circuit as well. The bulb is over here and it'll light up if we have any problems. It's a 150 watt bulb, so it should only light up if there's a serious issue. And I also have this multimeter here displaying our B plus voltage that's hooked up to the positive tab on our filter can capacitor. So without further ado, let's turn this on, and hopefully this voltage will come up a bit, but we won't have any big current draw because nothing in here should really be drawing current without the output tubes in. So let's see, let's turn this on. And as you can see, our input voltage right now is only about 30 volts, so not very much. And I think you'll see in a second, we're gonna start getting our B plus voltage coming up. There it is, it's starting to climb. So yeah, the rectifier obviously not working super well at such low voltage, and since our input voltage is low, our B plus voltage will be low as well. But I'll just slowly ramp it up here, and hopefully we won't have any issues, but I'm ready to flip it off if our filter capacitor starts to go south or make any humming noises or anything like that, which can sometimes happen. So let's see. I'm gonna up the input voltage a little bit. So far so good. I don't see any smoking. I don't hear any bad noises coming from here or anything like that. And it doesn't look like we have any shorts that would cause excessive current draw or anything like that. So that is good. And nothing out of our light bulb here. I'm gonna up this to about 50 volts. All right, so our B plus is coming up to above 120 volts here, 130, and still no issues. So that is definitely good. Of course, we don't have our signal tubes in here at all, so there could still be an issue with that part of the circuitry. That's just not emerging yet, but so far so good. All right, we're at 330 volts B plus, and still nothing bad is happening. So I'm gonna assume that everything is relatively fine with our filter caps. Well, we won't know until we listen to it whether or not the capacitance has gone low or anything, but they don't seem to be severely leaky or anything like that. They don't seem to be causing excessive current draw, so that is good. And yeah. All right, so now that I've tested the amplifier with just the rectifier tube and all the voltages seem to be fine, I'm gonna move on to testing with all of the audio tubes, the signal tubes installed. So I put those in. You can't see them, of course, they're on the other side, but I did plop those back in there. And I have this thing hooked up to an oscilloscope and to a 8 ohm load, and also a spectrum analyzer using an ADC. That's this ADC right here. So that's all hooked up in the back. Then I still have my multimeter hooked up here to show our B plus voltage. So yeah, let's get to that. And first I'm going to start again with just a low voltage through the variac, so that we, if there's any issues with the tubes drawing excessive current or any wiring issues and whatnot, we'll be able to spot those before we ramp up to full voltage. So yeah, without further ado, let's turn this on and see what happens with this. Probably it's going to be about 40 to 50 volts on the line. So let's see here. So far, our bulb is not really drawing much current, which is what you'd expect. Everything looks to be fine. Our B plus is coming up now, and our current draw, I'm gonna actually turn my multimeter back on that's displaying the current draw. It's 240 milliamps, that's very reasonable. So I don't think we have any issues here. Yeah, looks fine to me. So without further ado, I think I will crank this up a little bit more, and we will take a look at what happens when I try to pass a little signal through it. In fact, it probably would pass a little bit of signal now, but I'm still going to increase the voltage a bit more before trying that. So let's go up a little bit. Okay, I think that because our current draw seems to be totally under control, I'm going to turn this off and I'm going to remove the dim bulb tester light bulb from the circuit because it is really hurting our ability to get up to full voltage here. So yep, I'm going to do that real quick. All right, so now I've turned it on with without the dim bulb tester in circuit. Now it's just the variac, and we are going to see if we can get some more signal out of it and get some more voltage. So, all right, our output tubes are conducting, the current draw is coming down. So now I'm going to increase the voltage on the variac again. Okay, so this thing is pretty sensitive, so I actually need to lower the volume input a little bit. I had it way too high because it was barely conducting. Our output tubes were barely working at our previous line voltage that was very low. But now we've finally got the B plus high enough. The output tubes are really working, and so we need a much lower input voltage. This thing is quite sensitive. Even on the crystal phono input, it is very sensitive. So I'm going to bring the line voltage up even a bit more so I can show you what this really does at the voltage it's supposed to be at. All right, so I'm going to take this off the mount. So you can see we are at 320 volts on the B+. And if we look over here at the spectrum analyzer, we can see that we are doing, the voltage isn't quite calibrated. I'll show you what it is in a second. But our total harmonic distortion is negative 67 decibels. So the spectrum looks pretty good right now. Everything looks fine. No issues there. And if we come over and look at the output on the scope, we have a 400 millivolt RMS signal right here. Looks like a nice clean sine wave. No problems with that. So looks great so far, and it seems like this amplifier is working quite well. And as you can see, our heater voltage right now is 5.45 volts. So we're not quite at full voltage, but we're getting pretty close at this point. So what I'm going to do next is put this back in the mount and increase the variac voltage until we've got a little over 6 volts on the heaters, because that'll be about close to full voltage into this transformer. All right, so now I have the variac turned up to basically what I would consider a full operating voltage. It's a little bit below. Our heaters are at about 6.2 volts, which shouldn't negatively affect the performance really. And our B plus is at 377 volts. Thereabouts, it bounces around a little bit, but you can see it's about that much. And everything's still working fine. And our current draw is about 860 milliamps through the line. And I've still got it outputting a nice 1 kilohertz sine wave, as you can see over here. And this is a 2.83 volt RMS sine wave. So that's about 1 watt into 8 ohms. So that's a standard testing value, 1 watt into 8 ohms. And I'll show you the performance over here. We are getting about negative 57 dB of THD. So I would say that is respectable, negative 57. I'm sure this is about the performance this amplifier is intended to deliver. It's, not at the top of the end hi-fi amp of the era, but clearly there was a lot of thought that went into designing this thing, and the transformer is a peerless unit. That's a very nice transformer. It's not some sort of no-name, transformer. So this thing was designed to deliver, a reasonable amount of power and do it with reasonable fidelity, I would say. And that is what we see here with these results. And you can see that we have a lot of second harmonic distortion, much more second harmonic than third harmonic. So if that second harmonic distortion was reduced, we would actually have a much lower figure. Our third is down at a negative 77 dB, which is quite impressive. So yeah. This thing probably sounds really great, and it looks like it works so far. I'm going to quickly demonstrate the volume control, and we can also try the bass and treble control. So here, the volume control works as you'd expect. and seems to work quite well throughout the range of motion. So yeah, nice performance there from our volume control. Since we're at 1 kilohertz, I don't think that the bass or treble controls are going to do much. So what I'm going to do is go over to here, and I will, first we can try 10 kilohertz, which will probably give us, or maybe 15 even, which will probably give us our treble controls. So if we cut the treble by moving this to the left, yep, sure enough, if I show it over here, sure enough, we do see that it cuts the treble. This pot is a little bit iffy, not quite as clean as the volume pot, but good enough, I'd say. And lastly, we can try our bass control. I'm going to put this to, let's try 50 hertz. Better, honestly, better performance at 50 hertz than I might have expected. We're getting negative 45 dB of THD. I consider that seems quite respectable at 50 hertz. And so, our scope, we're going to need to change that. All right. And now I will, so this is actually, the bass control is a boost. So we're going to see if this boosts the bass. Let me focus this real quick. It does seem to boost the bass. I'll actually have to, actually it seems like the bass is already equally loud to everything else, and this is truly a boost control, so there's no way to tone down the bass. You just get to boost it. Ooh, whoa. Okay, this control seems a little bit iffy. It does seem to work. It just sometimes gets a little jumpy. If I go all the way down, you can see here. Yeah, it definitely works. I think it just has a little bit, this pot maybe needs to be moved around a bit more. But yep, our bass control. Now there's a little bit of weirdness in the bottom of the pot there. But yeah, our bass control I would say basically works. I think this pot has seen better days, but overall that does what it's supposed to do. So yeah, I think that's sufficient to demonstrate that this is clearly working. Unfortunately, I don't really have a great way to test the high gain settings. Actually, I could just plug this. I don't have anything that'll make use of the frequency compensation for the magnetic phono because I don't have any magnetic phonos, but I could just test the mic input real quick by just plugging my normal RCA cable into the mic input. So why don't I swap those cables, and we'll do that real quick to demonstrate that this thing is fully working. All right, so I have the amp turned on here and set to the mic input, which is one of the inputs that uses the first preamp stage. And the stage does seem to work because it is amplifying my 1 kilohertz signal, as you can see here. And the output level on my DAC is very low. 5 is a very, very low output level. Nothing else passes any signal at 5 that's appreciable. So it is clearly amplifying the correct signal. However, it's also amplifying this 50 kilohertz noise signal. And you can see it especially well on the scope. There is that 50 kilohertz noise right there. Well, it's not a noise, it's actually a pretty nice sine wave, but anyways, there is a 50 kilohertz that's being injected into this somehow, and honestly, I don't think this points to an actual issue with the wiring or with the amp itself. I think this is just a symptom of there being a 50 kilohertz noise that is present in my room, probably a switching power supply or something like that, and this is such a high gain input, a very, very high gain input, that I just think that especially given the fact that this thing doesn't have any bottom cover. It didn't come with a bottom cover, and I don't have a bottom cover for it. So that's going to really hamper the ability to suppress this type of a noise. So I'm not really sure there's anything I'm going to be able to do about this, or that it indicates there's anything actually wrong with the amplifier. I think this is just the reality of running, such a high gain input in a modern setting without a bottom cover. So I'm not really sure there's anything to be done about this. I'll probably just, when I sell this, you know, have a sort of a buyer beware that if you want to operate this on the high gain inputs that utilize the first tube, you're going to need to take precautions to suppress noise, and you might have to have a bottom cover built or something like that. But beyond that, not really sure there's anything to be done about this. This would at least be easy to do, and I'm not going to have a bottom cover fabricated just for that, because I think that anyone listening with a modern source is probably going to be using the crystal phono input and not either of these two very high gain inputs. And one more thing I realized I should do before I play some music through this and end the video is to get some distortion and test figures at higher power outputs rather than just at 1 watt. So that's what we're going to do. First, we're going to go up to about 6.3 volts, which is about 5 watts into 8 ohms. So I'm just going to crank the volume until we get there. And we're just going to keep going with this thing until we get to an unreasonable amount of distortion. I'm not going to push this thing, you know, to the breaking point. I just want to see what it can do reasonably. So, all right, getting close to 6. All right, this is a little over 6.3 volts. And we are at negative 49 dB of THD. Let me negative 49 dB. So that's at 5 watts again. Not bad, not bad. That's about what I expected given what we had at 1 watt. Tube amps the distortion tends to rise pretty substantially as you increase the power output. So that's about what I'd expect. And let's just push this as far as we can get. I'm going to stop at maybe negative 25, negative 30 dB of THD. All right, so now at about 10 volts output, which let me calculate real quick here. Not the best at doing this math in my head. That's about 12 watts and still going pretty strong at negative 40 dB. So this thing I would say does a solid, 12 watts. And you can see over here, does a solid 12 watts. Let's see how much higher we can go before we hit about negative 30 dB, which I would consider is the, okay, once we get to, so now we're really starting to clip the waveform, as you can see over here. We're really starting to clip that waveform, so distortion is rising substantially. Oh, yep, look at that. Definitely clipping, and the clipping is a little bit unequal, so that's not ideal. We could, if I really messed with the bias of this thing and changed the operating points, I could probably get a little bit more out of this at high power, but we're not going to do that. But you can see that now we're at negative 27.7, so yep, clipping pretty badly there. And this is at about 11.8 volts RMS. So we didn't get much further. I would say this amp is good for about, 15, 16 watts of power would be the max you would reasonably get out of this. Which makes sense. This looks like kind of a low, it's a low B plus kind of class A-ish, probably not quite class A, but you know, it's a low B plus, low power 6L6 operating point. So that's a reasonable amount of power. It's about in line with what I'd expect. So yep, not too many surprises there. This is about a 15 watt amplifier. And yeah. All right, so I think that's going to be about it for this video. I don't really have anything else I want to do with this amp. I think it's working quite well, and I think my restoration of it is pretty much done. So yeah, I hope you enjoyed, and I'll have more tube amplifier content coming soon. I'm still working on my 6L6GC balanced amp project. That's kind of a long-running project. And I also am restoring a Magnavox console amp. That's next on my list. So yeah, I hope you enjoyed the video and enjoy listening to this amp. I'm going to play a cool cover of Gerudo Valley from Ocarina of Time, and I'll link that in the description below.